The journey of an object moving in a helical pattern is a study of perfect balance between different types of movement. By looking at the underlying logic, the physical results, and the way we visualize these paths, we can understand the complex nature of this three-dimensional spiral. The foundation of understanding this motion lies in tracking an object's position as it evolves over time. To determine how far the object is moved from its starting point, one must consider its displacement across all three dimensions of space simultaneously. By studying the rate at which this position changes, we can define the object's velocity, and by further examining how that velocity shifts, we uncover the acceleration. Interestingly, the acceleration is tied directly to the horizontal components of the object's position, reflecting a continuous pull toward a central axis. In physical terms, a helix is created through the superposition of two distinct motions: a uniform circular rotation in a flat plane and a steady, constant climb along a vertical axis. This combination results in a trajectory that maintains a uniform radius and a constant pitch, meaning the tightness of the spiral never wavers. One of the most significant traits of this motion is that the object's overall speed remains entirely constant throughout the journey. Because the speed never fluctuates, the total distance traveled, often called the arc length, is simply proportional to the amount of time that has passed. To bring these abstract concepts to life, computational tools are used to translate mathematical logic into a visual experience. Digital scripts calculate the precise coordinates of the path and then project them into a three-dimensional environment. These visualizations often include a top-down view to emphasize the perfect circularity of the base motion, while interactive animations use tracing lines and moving markers to show the object's real-time progress. To make the experience more immersive, the virtual camera can even rotate during playback, allowing the viewer to appreciate the depth and symmetry of the helical structure from various perspectives. By balancing high-precision calculations with smooth visual playback, these models confirm the theoretical constancy of speed and the elegant uniformity of the spiral path.